Okay, just one more video, applications of logarithmic functions. So you would have heard of these before, so Richter scale, and then we'll be looking at a question on decibel scale and also pH. So on the Richter scale, the magnitude R of an earthquake of intensity I is given by this formula. R equals log to the base 10 of I over I sub 0, where I sub 0 is a reference intensity used for comparisons. Now it says find R for an earthquake that is 4.3 million times more intense than the reference intensity. So I will be 4.3 million, which is 4.3 times 10 to the power of 6 more times more intense than the reference intensity. So that times I naught, which is 4.3 times 10 to the power of 6 I sub 0. So therefore R equals log to the base 10 of is I over I sub 0, which is 4.3 times 10 to the power of 6 times I sub 0 over I sub 0. Now the I sub 0's cancel, and we get log to the base 10 of 4.3 times 10 to the power of 6. So you can just enter ln 4.3 times 10 to the power of 6 on your calculator. So we're going, no, not ln, sorry, you do log to the base 10, so you press log 4.3 times 10 to the power of 6, and in brackets we get that it is 6.11 on the Richter scale. Okay, so if you look up 6.11, I think that's fairly strong, but there are earthquakes like with 7 or 8 on the Richter scale that are even, actually I'm not sure if I entered that right, I'll just check. Log of 4.3 times 10 to the power of 6, and that's 6.63, sorry, 6.63 I'm getting on the Richter scale. Now, question B, it says an earthquake measured 8.5 on the Richter scale, so that's obviously stronger than this earthquake here. So we've got R equals log to the base 10 of I over I sub 0. So if it measures 8.5 on the Richter scale, so R is 8.5, the question is how many times more intense is this than the reference intensity? So that equals log to the base 10 of, now I'm just going to put, we're going to have a number like we did before times I sub 0 over I sub 0. So the I sub 0's will cancel. So I'm just going to put I there, okay? And so remember 10 to the power of 8.5. So 10 to the power of 8.5, I'm just going to put equals I, and that's how many times it is more intense, because this really should be I times, well, I is a number times I sub 0 over I sub 0, and the I sub 0's cancel. All right. Actually, I might just call it X for now. So X equals, so I'm going to say let X equal, I'll work it out in a minute. So 10 to the power of 8.5 equals X. So X equals 10 to the power of 8.5. Now remember, X is some quantity times I sub 0 over I sub 0. So that the I sub 0's cancel. So therefore, it is 10 to the power of 8.5 times more stronger than the reference intensity. So this is not 10, so if you enter that on your calculator, 10 to the power of 8.5, you get, this is what we get, 316227766. So counting back, we've got that it's 316,000, sorry, 316, so the other one was 4.3 million times more intense. This is 316 million times more intense or 3.16 times 10 to the power of 8 times more intense, okay, than the reference intensity, which is I0, okay? Okay, let's look at the decibel scale now. So the Richter scale measures the magnitude of earthquakes. So that's a logarithmic to the base 10 scale. And here is another logarithmic to the base 10 scale. It's the decibel scale. Now, on the decibel scale, the loudness of a sound, intensity S, is given by this equation. L equals 10 times log to the base 10 of S over S sub 0, where again, S sub 0 is a reference intensity. Now it says a sound that causes pain in humans is 10 to the power of 14 times more intense than S sub 0. Find L, which is the loudness, all right, for a sound of this intensity. So L equals 10 times log to the base 10. Now they said it was 10 to the 14 times more intense. So it will be 10. So S is 10 to the 14 times S sub 0 over S sub 0. Okay, so that's what S is. It's 10 to the 14 times S sub 0. So the S sub 0's cancel. So the loudness is 10 times log to the base 10 of 10 to the power of 14. Okay, and you can enter that on your calculator. So you'll press 10 times log, because that's log to the base 10, of 10 to the power of 14. Okay, and it should look like this. 10 times log, which is log to the base 10 of 10 to the power of 14. Now, actually, you could work this out without even using your calculator, because this 10 can stay here. This 14 goes to the front, so it's 14 log to the base 10 of 10. So 10 times 14 is 140 times 140 there. Log to the base 10 of 10 is 1. So we should get 140 on the calculator, and we do. So you actually don't even need the calculator for that calculation there. All right. Now, the next one, just working backwards. How many times more intense is the sound of a heated argument, which is about 67 decibels, than the sound of a quiet room, which is 31 decibels? So we'll have to substitute into the formula twice. We know that L equals 10 log to the base 10 of, for the first one, oh, we know the sound. I'll actually just write the formula out. So it's S over S sub 0. So in our first one, we've got the heated argument, which is 67, equals 10 log to the base 10 of S over S sub 0. And it's saying how many times more intense is that sound than the sound of a quiet room. So looking at the quiet room, 31 equals 10 log to the base 10 of S over S sub 0. So just rearranging the first equation. Actually, I should probably just put this one over here. So let's just work out what this bracket is. So I'm going to divide by 10 first. So I've got 67 over 10 equals log to the base 10 of S over S sub 0. So that means that 10 to the power of that. So that is 6.7. 10 to the power of 6.7 equals S over S sub 0. Okay? So, and we can just work out what that is. So S over S sub 0, just 10 to the power of 6.7. Well, I'll just leave it like that for now. I'm getting, or I can just do this, 50,11872. That's what I'm getting. So 0.336, okay? And if we just look at this one, 31 divided by 10 equals log to the base 10 of S over S sub 0. So this is 3.1, so 10 to the power of 3.1 equals S over S sub 0. Now 10 to the power of 3.1 is 1258. 0.925. Okay, so it's asking how many more times intense is the sound. So if we do this divided by this, because S is sound, okay? So a sound that causes pain in humans is about 10 to the 14 times more intense than S sub 0. So they're just asking how many more times intense is this compared to that. So if we divide, so we've got 50,11872.336 divided by 1258.925. Okay. And you get 3981. So it's 3,981 times more intense. So I worked out what those two values were. The other way you could do it, if you want the exact value, you would go 10 to the power of 6.7 divided by, what we're really doing is this answer here, which is 10 to the power of 6.7 divided by this answer, which is 10 to the power of 3.1. And you know when bases are the same and you're dividing, you subtract the indices, so it'll be 6.7 minus 3.1, which is 10 to the power of 3.6. Now, if I look up what 10 to the power of 3.6 is, I should get 3981, and I do, okay? So that is approximately 3981. So therefore, it is 10 to the power of 3.6 times more intense. So the answer is 10 to the power of 3.6 times more intense than the quiet room. Now, that value is 3,981, or approximately 3,981. Now, just some chemistry applications here. So some of you may have seen this in Year 11. So the pH value of a solution is given by the formula pH equals minus log to the base 10 of the hydrogen ion concentration. So we're H plus in square brackets. That is called the concentration of hydrogen ions in moles per litre. Okay, and the first question is to find the pH values of each of the following, where the your pH of blood, which is a hydrogen ion concentration of 3.98 times 10 to the power of negative 8. So pH equals negative log to the base 10 of the hydrogen ion concentration, which is negative log to the base 10 of 3.98 times 10 to the power of negative 8. So you can just enter that as negative log on your calculator of 3.98 times 10 to the negative 8. So we've got negative log 3.98 times 10 to the power of negative 8. And you get a pH of 7.4. Okay, so that's a pH of 7.4, slightly basic for those that remember their junior chemistry or are studying chemistry. Remember that pH is on a scale of, 1 to 14, okay? All right, now pH of beer. So pH equals minus log to the base 10 of the hydrogen ion concentration, which is minus log to the base 10 of 6.3 times 10 to the power of negative 5. And on your calculator, you'll just enter that as negative log, so log, 6.3 times 10 to the power of negative 5. And you get a pH of 4.2. So this is acidic, okay? And now just doing some questions in reverse. You have to find the concentration, or the hydrogen ion concentration, so the H plus in square brackets for concentration, in moles per litre for the following. So eggs have a pH of 7.8. So writing out the formula, pH equals minus log to the base 10 of the hydrogen ion concentration. So the pH here is 7.8 equals minus log to the base 10 of the hydrogen ion concentration. Now using, let's take this negative over to the other side. So negative 7.8 equals log to the base 10 of the hydrogen ion concentration. So now writing this log as an index, the base here is 10. So we've got 10 to the power of negative 7.8 equals the hydrogen ion concentration. So the hydrogen ion concentration is 10 to the power of negative 7.8. Now you need to put that into your calculator to get a concentration that looks like something in scientific notation. See, this concentration here is in scientific notation, a number between 1 and 10 times 10 to a power. Okay, so you need your concentration like that. So you need to put 10 to the power of negative 7.8 in your calculator, and you get 1.58 times 10 to the power of negative 8. So that's your hydrogen ion concentration. And water, so we know that pH equals minus log to the base 10 of the hydrogen ion concentration. pH of water is 7, which is minus log to the base 10 of the hydrogen ion concentration, taking the negative over. So we've got negative 7 is log to the base 10 of the hydrogen ion concentration. And now writing it as an index, we've got 10 to the power of negative 7 equals the hydrogen ion concentration. So the hydrogen ion concentration is 10 to the power of negative 7. And those studying chemistry will recognize that. You will have seen that, okay, as 10 to the minus negative 7. So you can leave that, or you can put it into your calculator, and well, that one is just the same. 10 to the power of negative 7 is just 1 times 10 to the power of negative 7. Okay, and that's it.